All right, this is part 3 of our introduction to metallurgy and the historical aspects here. So just a real quick review of part 2. So we talked about how inventions and innovations during the Industrial Revolution led to better steels. That metal was used, that we used was cheaper and faster, and of course, used metal made industrialization possible. So if you think about the Industrial Revolution, we've got the mechanization of tools and machinery. We have the steam engine and the development of the steam engine. We've got the railroad industry led by Dale Carnegie here in the U.S. that had railroad ties needing to be made and truss bridges needed to be built as transcontinental railroad was put in place. And then, of course, we've got skyscrapers that started to come out, in the late 1800s, early 1900s, as the race between New York and Chicago started to take place. We have the development of different types of furnaces in the 1850s, starting with the Bessemer converter, the open hearth furnace. Then we went into the basic oxygen furnace, the electric arc furnace, and continuous casting. That all kind of made the production of steel cheaper and easier, and we also had the production of aluminum starting to come out as well. So, which is kind of where we'll go here next. In 1957, Alcoa built the first aluminum beverage can production line. So, and of course, we started to use aluminum sheet, which was easier to form than steel. Those of us that are old enough to remember tin cans, so beverage cans back in the 1970s, when I was younger, used to be made out of tin. And of course, the canning industry as a whole, your green bean cans, a lot of these cans were made from actual steel. So as we got into the 50s and then in the 60s, aluminum started to become much more widespread. So we determined and figured out how we could process the aluminum into sheet, and that aluminum was a lot easier to form than steel was. And not only was it easier to form than steel, aluminum was a lot easier on the tooling required to form and make it as well. So you got a reduction in your cost of your tooling as well. So matter of fact, when I served my apprenticeship, the original owner of the shop used to always talk to us about making sure that we were drinking our drinks out of cans, and that we were buying actual, instead of buying like vegetables out of jars, to buy them out of canned vegetables as well, because we made all of the tooling that would go into making those particular products. So as the tooling wore out, that meant we got more orders and could make more tooling parts as well. So you had savings in tooling cost as well, because aluminum was easier to form. You also had cans that are lighter, and so that reduced your shipping cost. And of course, nowadays, all through like the 80s and 90s, aluminum was definitely dominating the beverage market. We still do have a lot of aluminum cans, but now, of course, we've also got a large amount of plastics involved in the canning industry as well. So as we get into recent developments here, so we have what is referred to as DRI, direct reduced iron. So this is where we are actually using gases like methane and carbon monoxide, hydrogen, to try to remove oxygen from iron ore. This is done in a solid state, so where it's no longer needed for melting. This direct reduction of iron leads to higher purity, so it also reduces costs. And the big aspect here is in regards to pollution. So, in traditional old world melting and smelting furnaces, you think about those blast furnaces and the coke production and the amount of pollution that's going into the air. Now with direct reduction of this iron, we can kind of remove some of these impurities and help us in terms of our emissions to try to reduce those greenhouse gas emissions. Likewise, the big development, there's also been other recent developments in terms of additive manufacturing. Now, I'll talk not just about additive manufacturing, but we've got additional types of composites that are being made and additional changes in plastics that are also being developed. Of course, we're predominantly focusing on metals um, in this particular class, but we do have a recent development with additive manufacturing, so or 3D printing. Now, 3D printing is nothing new. It's been around for at least 20 years of my career, if not longer. As a machinist, I will tell you it's always kind of been a love-hate relationship for me, um, predominantly because a lot of students, they see uh, and get instant gratification when they design a part and get it printed on a printer so that they can have instant success and see what they do. But they tend to forget about all of the other manufacturing processes that are out there. Now, I will also mention that 3D printing, in my opinion, still has yet to get to a point where we can really use this in a production capacity. So, because the 3D printing process is actually pretty slow. Now, when it first came out, it was widely used for production or for prototyping. So that you would use this as a prototyping tool to kind of prove out your concept and make sure that it would work before you actually went into um, making a full working prototype out of the actual materials. Of course, in the last 10 years, we've gotten a lot better and the ability to actually fuse and make metals and so forth out of 3D printing. It is starting to be more widely processed. There are other dangers associated with metal fusing and the 3D printing type of process and the gases that are incurred. I'm not 100% sure that it is still uh, truly cost effective from a production standpoint. There are certain types of parts designs that are only able to be produced by 3D printing, but for those of us who are involved in machining parts or welding parts, or even just engineering and coming up with processes to make and engineer some of these parts, I think that the main takeaway here in my experience has been that this should be like a last um, result effort to try to use this for production materials. Try to think of the other ways that we can produce and manufacture parts and the other processes before we consider 3D printing as a viable way to produce parts. But you do have this as a technology that's available to us now. And of course, we get into nanomaterials now as well. So these are definitely engineered materials, very small particle size. We were starting to see new material behaviors. So I guess the long-term range here, well, we've spent these three um, lectures kind of talking about the history of metallurgy. Would be remiss to not point out that metallurgy and the use of industrial materials is a ever-changing science. So engineers and scientists are continuing to come up with new materials that meet the demands that we look at for all of our industrial needs. So it's still kind of a wild frontier as we go down into newer space age polymers, plastics, composites, and nanomaterials, and especially as we use up different natural resources, we have to come up with other materials that still give us great strength um, in order to meet our demands for future.